Greetings! Welcome to the workshop. I've decided to move to try YouTube Live. I had before tried this out on Twitch, and Twitch is fine for other things, but maybe not so much this. So, hello, welcome. Oh dear, hang on. Right. Still obviously trying to figure out YouTube Live. I'd like to get some kind of window into chat. That would be nice. But hey, it's our first day, so you know what can you really expect? Right. I think we'll do a few things here first. First thing, where do I put my coffee? It's actually coffee today. It's quite nice. I think what we'll do, as promised, is some kind of post bag, mail bag sort of thing. Now, God, I really wish that I could. You know what? I'll just run this on the phone. We'll turn the volume down. And now I should be able to see a really delayed, 30 seconds delay, version of myself here on the screen in glorious 144p, which is fantastic. Right, let's go ahead and open up some mail. I don't tend to get a lot of mail, but I've recently been trying to equip an electronics lab. So, let's do it. Got our first package here, which is from... where is it here? Well, it's from China. Yeah, it looks like it's from, Baon 43 area. Anyway, good times. I know the place well. It has good dump. No, I've got no idea. Don't know where that is. Any event, it's in China. So let's see what we've got. Ah, good. This is something that, if you're prototyping, you will always want more of these. This is an order that I placed, oh god, quite some time ago, for 5 MB102 boards. That's an 80, what is it, an 830 tie point solder with breadboard. It's fantastic. That's used for prototyping. So if you have through-hole components, I guess they're also called THT, right? Through-hole transistors, which they're just your standard componentry. So, for example, I don't know. Let me pull something. For example, these are, what are these? These are microchip. Sorry, Motorola devices. What are these? These might be like hex. Like hex inverting. Like shot or Schottky stuff. It might be that. Anyway, these are an example of a chip that you could mount into a breadboard. So, for example, for a little bit better example, let's do this. This is a much smaller breadboard that I've got actually wired up to resemble an Arduino. So what you're seeing here is this breadboard can run the blink sketch. There's an LED. It is mounted with the 16 megahertz crystal, which of course, you know, has the correct caps on it. I've got a decoupling cap here for the rail, for the voltage rail, and I've got a USB to, what would this be, like serial little converter board. It is not a FIDI chip-based board. It is probably a CHG or a CH340G based affair. And indeed, that does seem to be the case. So, once I have, this is let's do this with the stabby implement. This is an ATmega 328P PU integrated circuit, so it's an IC. It's DIP, what is that, 28 package, which means there's 14 pins per side and 2 rows of pins, right? That's pretty standard fare. What this means is that you can mount this on a breadboard, as I've done here, and how a breadboard works is all of these tracks are, like everything in this row, is tied electrically. So for example, you can see I've got a ground connection tied to this pin, and a... what am I doing here? Let's see here. This looks like crystal... what would this be, actually? I'll bet this is VREF, like VCC, and maybe like analog voltage ref. I'd have to go look at the pinout to actually have a very good idea about what that does. In fact, you know what? I'm looking at it the wrong way around. So pin 1 is over here, which means that, yeah, my crystal is going to be on pins 9 and 10. That makes sense, right? Because they come in to here. That goes to the crystal, which then goes to ground across a couple of capacitors. That's fine. That makes sense. So in any event, this whole breadboard is the same as what you get if you went and bought an Arduino board, which can look, well, one example would be like a Nano, which is this board. And when I say this board, I mean this one right here. This is a, I think it's a Nano 2.0. This is a Nano 3.0. This makes use of an Atmel ATmega 328P AU. That's the... Alright, so it's the same chip as here. Here's the IC that I'm pointing to on the Nano. This is a... well, let's see here, 328P AU is going to be low power, right? That's the P. And AU means it will be TFQP 44-pin package, as opposed to PU, which means 28-pin DIP package. What does that mean? Well, it's very, very, very small. It's exceedingly small. So for comparison, yeah, I've got my finger next to it, and I don't have enormous gorilla hands, so it's pretty small. I guess I could use the USB connector here, just as a scale. Again, that chip is pretty small. What this does is this is actually a boot programmer for a naked 328P PU IC, because these chips don't have the Android bootloader flash to them by default. So what I do with them is I, take a naked 328P PU chip, I throw it into my ZIF socket here. This it's a way of just getting chips very quickly, in and out and latched down. I then connect the Nano up to my PC, flash the bootloader across. This chip, this Nano acts as a sort of an intermediary device. It programs using ICSP in circuit serial programming or software programming. I'm going to say in circuit serial programming. Anyway, it's these pins on the back of the device. That's your ICSP header. It's a 2x3 or 6-pin header. And I've also got the reset and a couple digital lines here. Pushing data over to my receiving device, my receiving sort of little breadboard. In any event, the gist there is this is how I flash a bootloader to a naked 328 PPU chip. From there, I pull it off of this ZIF socket, mount it temporarily to this breadboard, where I then use the USB connector to flash Arduino code using the Arduino IDE onto the chip. Now, this is for development work. I'm looking to build some commercial products, and what I'll probably do with those products is I'll probably use the 328 PAU format, which is, again, this chip on a PCB. And what I'll probably do for programming is what will I do? I'll probably leave a pad or sort of pogo headers on the circuit board so that I can come in with a jig, press the pins down, go to my computer, punch program, the image gets flashed over, release the jig, and then the device is programmed and I can start testing. Of course, I could also have electrical test points manufactured in as part of the process. Dave Jones of EEV blog has an excellent video about that topic. I'm not there yet. I'm not even close to being there, but these are all considerations that you want to make and that you start making as you build for consumption. It's a very weird thing. It's a very strange transition to go from hobbyist to, all right, now I want to build something for other people to use and run and and enjoy. That's a very different, wildly different thing, because, for example, what you've seen there, sure, I'd put up with that for prototyping, but I'm not going to push that into the world as a finished product. No way. Just going to open up one of these MB102 packages to show off the breadboard. This looks like not terribly bad quality. Yeah, that looks okay. That looks okay. So again, you have your breadboard. You can, let me just do this. You can take your IC or another through-hole component, and you can actually mount it. I'm going to go pin up. We'll start with pin 1. You can mount it into the breadboard. Now, prior to doing that, let me just move some of this out of the way here. What you might be able to see is that the ICs are shipped slightly spread apart. Right, the pins are a bit spread eagle. I'm sure that's the technical term, spread eagle. Yes. So, what you can do if you're a filthy hobbyist, you can just sort of mash them down on the workbench. But if you want to do a little bit better, you can get an IC lead straightening tool from Jamco, which is this black tool, and that will let you sort of mash the pins appropriately such that they fit right into your breadboard. And we'll go ahead and let's push this down, being careful not to press on the pins themselves, because they are ESD sensitive. They are really quite sensitive. And now you can see this IC has been pressed into the breadboard. It's very simple, right? So you do that times 1,000, and there we go. You've got a product at the, well, you've got a prototype at the far end. So, you know, victory. That's how that works. Let me go ahead and pull this IC out. I used to have better chip pulling tools. I don't right now. And I should probably invest. You know, I hate rebuying tools, but maybe here it will be worth investing the couple dollars into the bent steel tool as opposed to the sort of plastic insect mandible kind of tool. And anyway, that's okay. One more fire for me to put out. Not right now. Right. So that's what breadboard does. You can see there's a center channel, and if you're using an IC, which is a DIP, a dual inline package, I don't know, form factor, you can straddle this center groove, and then, for example, your pin 1 is connected through on 1 A, B, C, D, E. Well, A, B, C, D, because you'll take E, and likewise pin N will be connected on the other side to these sockets. Pretty good way to go for through-hole components. The breadboards make prototyping pretty quick. You can change your mind really quite easily. You can sort of throw things together. You can prototype fairly rapidly. There are a couple of problems, though. One is that the connections, of course, are not going to be anywhere near as good as a soldered connection, or a trace with some solder paste or anything like that. But again, for prototyping, very, very, very useful. Right, that's my first product received. Now I'm opening these, and I don't honestly know what is inside. I really don't. So we've got another package here from Guangdong, China. It's just a sort of a it's actually paper. It will be sort of probably a padded paper envelope with adhesive fold-over flap. I'm opening these off screen because I haven't blacked out the address. I'm not quite sure that I'm ready to start having random coffee and biscuits show up at my place. That seems a bit. I think I'll wait a bit till I'm a bit closer to release to do that. I'll never expect it, but here's dreaming. Wow. Okay, I know what this is. This is good. So, packaging. Packaging is always curious. It's also curious to me that normal people are paying for shipping and charging $0 to ship a package across the world. I mean, I don't know. That's magical to me. It really is. But the flip side of that is, well, this is bubble wrap, which is going to be super staticky. Hopefully there's not any ICs in here, any transistors, any components. Hopefully it's all going to be... Oh, good, I know exactly what this is. Well, okay. So we have the box of random... Yeah, I know exactly what this is. Box of hardware. This is actually going to be plexiglass or lucite or some other kind of acrylic material. We've got some mounting hardware. Oh, this is so good. And unfortunately, hang on, I think that I see a foil bag. Oh, brilliant. Okay. So, whomever shipped this is not completely, well, mean, but they're just mostly. So, yeah, there we go. I've just touched a grounded spot here. I do have an ankle strap that right now is hooked up to nothing, which is not how I'm going to run. But anyway, this is none of this stuff will actually leave. This is all my own, test harnesses, test jigs. Anyway, this is very exciting. I guess ESD can't really do too much to this right now. There's nothing on this particular IC. No, it's not an IC. Sorry, PCB. This is a through-hole component, clearly, right? Because you can see there are, well, there are holes. Through-hole. That's what through-hole means. It means, there are discrete electronic components that will go through the PCB, through the printed circuit board. This is probably a 2-layer board. This sure looks like a 2-layer board. That's fine. Anyway, this is labeled here. That's weird. They wouldn't silkscreen this. It's labeled underneath the solder mask, which is really weird. So they etched, but they didn't silkscreen that. That's a really strange move. But anyway, it's transistor tester. I'm pretty happy about that. Now, here's the exciting thing to see. It's a foil bag. It's a, well, metallized bag, if you will. This is quite good. This is how you want to ship components. Now, we're almost doing okay here because I think the screen is plunged into some white styrofoam, which I don't think is ESD stuff. I have some ESD foam. For example, this is ESD foam. I've seen pink, and I've seen black, but I don't think that white comes with that option. But, hey, maybe I'm wrong. For example, this is another type of anti-static foam, of ESD foam. Effectively, you punch the, well, as you saw me do with the IC earlier, you actually press the pins into the foam, and that shields them, that protects them a bit from ESD, electrostatic discharge. So anyway, very, very, very exciting. This is an AT Mega 328. Yeah, here we go. It's 328P. It is a PU. So you can see, oh, here. You can see there is the silk screen and all the holes for an AT Mega 328P PU, because it's through hole, it's a dip package to go through. So this is a well, the same chip that runs Arduino, although I don't know what this is going to be. Anyway, it's that same chip, and we have in the package, we have kind of what I'd expect to see, right? We've got a socket. This is missing a couple pins. But, these are, I don't know, 3 cents a piece. These are pennies. And when you're working on projects with through-hole components, certainly, with your expensive components, so your microcontrollers, which is what this will be, you really want to invest the couple of pennies in a socket, and you want to solder that socket down, and I'll show you pretty much how it's going to go. Let's line up the pin 1 notch here, and of course these legs are all bent because these are some pretty cheap sockets. I've got some replacement ones, but that's okay. And yeah, these are in wow, the legs are entirely bent. In any event, you would drop the socket down into, wow, yeah, these are, I'm somewhat impressed at just how off these pins are. Now, I should use my IC lead straightener, but I think officially, meh, that's what's happening here. There we are. So, what you do is you'd solder from the backside. You typically tack a couple corners and then just run, your solder down here. And then from the top, you have this kind of arrangement, which you want to protect your expensive part. So if you overvolt or reverse polarity your IC and smoke comes out of it, out of your micro controller, you can just pull the old chip, put a new one in, and then you're done. You don't have to go to the backside and desolder all of your contact points and stress out the solder mask resist and all the rest of it, and stress the pads. Very good practice. That very good practice. Yeah, so this pretty much has everything that you would expect. Kind of looking through the bag. No, this looks pretty good. So at the end of the day, this is going to let me test capacitors, which I can't test right now. It'll let me test resistors, diodes, Zener diodes, I believe. What else can it do? MOSFET, so like PNP and NPN junction, FET. I know it can do MOSFETs. I don't know if it can do other types of FETs. And of course, what is FET? I want to say like field electromagnetic theory, but that's not right. Anyway, it's a way of having a switch, for example. It's another transistor. It's a 3-pin device, which I know is super vague. But anyway, when I assemble this, I will be able to test those devices. And in fact, this is really quite good soldering practice, because I have an iron, I've got some solder, so I just picked up some 6337. I don't use ROS in my own builds, in my own, mad scientist experimentation. ROS is ROHS, it's reduction of hazardous substances. It's lead-free. I go leaded, lead-based in my solder. And that's, again, when I'm doing this for my personal use, that is my decided personal preference, and yeah, I don't deviate from that, because, well, the short of it is that the lead-based stuff is a lot better. It's much better to work with. It has a lower melting temperature. The joints are better. There's no tin whiskers that show up over time. It's just much better stuff. And of course, globally, you think that, using the leaded stuff would be quite good because it cuts down on rework, it cuts down on waste, it cuts down on environmental impact. Unfortunately, if you want to ship products into the EU or the EC or whatever we're calling that now, you have to use lead-free solder. So you have to be ROS compliant. And in my case, the biggest part of that is going to be using lead-free solder, which at that point I'll probably send my PCBs out to a fabrication plant in China, and I will have them use, lead-free solder, and I won't worry about it. But in the interim, and until I get to sort of, minimally viable product stage, I'm going to stick with my leaded stuff because it makes better joints. That's quite nice. So, next package is a filthy, it's from Thailand. A filthy gray, possibly white at one point, sort of plastic bag. This will probably have I don't know, maybe some padding inside. Maybe it won't. Maybe that's just wishful thinking. But yeah, this is from Thailand, as I said. And again, I have no idea what's in any of these packages. I know that I had ordered some components, I had ordered some hardware, I had ordered random things, and then I left the country on vacation for 3 weeks. So, truly, I really don't know what is in these bags. It's exciting for all of us. Yes, I'm pretty sure I know what's in here. After, of course, saying that I've got no idea what's in any of the bags. I believe this is a double-sided PCB. 200 mils by, what, 150? Is that what I ordered? Something like that. In any event, I think that's what it is. I've got a couple more. Alright. Alright, hang on. Going to have to persuade this a little bit. Wow. Okay, maybe we won't. Maybe we'll just cut, I don't know, maybe we'll cut everything open. Right. Yeah, so I've got a lot of parts that have shown up. I track all of my shipments, and it's pretty chaotic, actually, between eBay and now Alibaba. I've just introduced that into the mix today. Earlier I ordered a mat, because as you can see, this is not a good work environment. But then, of course, I noticed that I'd ordered the same mat from Banggood a month ago, and that has not yet shown up, which is really quite annoying. Right, let's see what we've got. Yep, indeed, this is, wow. This is a, wow. Yeah, that's not really what you want here. Yeah. This is a disgustingly fingerprinted and filthy PCB. Fingerprint. Wow. Oodles of fingerprints and some nice scratches. So, hey, you know, hopefully I wasn't wanting to use that second side. Oh, wait, that's right. That's why I bought a two-sided board. Well, hopefully these are just surface scratches. I think they are. I know I have a ruler, but in any event. Yeah, that's 200 mils. That's fine. It is FR4, which is your typical sort of fiberglass sandwich. It is just a oh god, everything's just so grimy. And there's another fingerprint on this. Brilliant. Yeah, so I'm not quite sure how much the camera is going to pick up, but wow. I am new to buying PCBs, but I know this is not abnormal, but it's not optimal. And I don't know. As I said, look, you know, I'm new to buying PCBs. I understand. Maybe it's just me. Maybe I don't know what I'm doing. That's always a possibility. But my own inclination when confronted with the question, or with the fear that I don't know what I'm doing, is, so for example, here's how I would handle this board, right? Boom. Very simple. Very, very, very simple. I would just grab it by the sides. Wow, this is really marred. I don't know. Yeah, I think this will be usable, but yeah, this is really not great. And you can see we've got at least 3 good chunky fingerprints on there. I wonder if there's a thumbprint on the other side. No. How did this happen? Oh, I know how this happened. This was an outside board. Somebody grabbed a stack of, I don't know, 5 or 6 and just dropped one in each bag for shipping. That's how we have this lovely. It's almost like a fleur-de-lis. Yes. That's the fancy sort of, I don't know, spray of 3. It looks like a floral kind of design. It's what the Normans used on their battle flags and their livery, for example. Yeah, good times. So that, disappointing but not unexpected. So I think maybe what we'll do, because I have just a couple more packages, maybe, and I've just opened up, really? 3. Here we are, 3. Maybe I'll open up another one and try and find my cover, my heat-resistant silicone cover, or mat, rather. I really hope there is something that looks large enough. Could this possibly? Yeah, it feels like it. Right. I've got only 2 more packages left in the chair of package reception. So I think we will open them up. Yeah. So again, filthy, grimy, black, grayish bag from Singapore. From a P.O. box in Singapore. Wow. Alright, that's, well, that's different. Let's go ahead and open this up. Yeah, so I do watch, I just want to take a moment. There is a good, I'm looking at my own screen, my stream preview here. There's a good, I don't know, 30 to 45 second lag. So this won't be real time. Anyway, yes, here we are. This is quite good, although it may never become unbent. Just make sure there's no... Yeah, there we go. Good. Right, here we are. Silicone, heat-resistant, BGA soldering maintenance platform. God help me if I'm soldering BGA. BGA's ball grid array. Yes, you don't do that with hand soldering. You would reflow that. Well, no, or you could use hot air. I suppose you could use a hot air station, but I don't have one of those yet. I don't have a heat gun. So you see, my options here are limited. Although, I would like to buy a toaster oven. I'll have the only sort of $10 Goodwill toaster oven that I turn into a reflow oven in the city, I think. But hey, that's fine. I'll probably get a thermocouple and write some code, make a sort of a reflow oven out of it, and I think, yeah. Anyway, that's what I'd like to do. Then I will be able to rework BGA. But now I'm not. Oh, okay. There is a strong wintergreen. like highly industrial wintergreen smell. That is really quite unexpected. Wow, I really wasn't expecting that. Right, well, we've got a bag which, I don't know, it's heat sealed, but not heat shrunk. Very weird. Anyway, this is a 340mm by 230mm heat resistant silicone mat. And this is going to be great because, well, right now I've got my table here, which is a slat design, which, you know, is perfect workbench material. And I've got the pie plate of soldering over that way somewhere, which again is not terribly useful, but this will be quite good. Oh God! Right, so oh man, the stink off this. It's a bit like industrial wintergreen smell is in a brothel full of rubber sex dolls. I don't know any other way to describe it. I'm sure that's the very best way to describe it, but yeah, very, very strange, highly strange smell. Not unpleasant, but really bizarre. Very, very unexpected. I'm not sure, in fact, if I've ever smelled this smell before. Anyway, it's a is that an A? No, that's an O. So it's a DuNu silicone heat resistant I don't know, pad? Yeah, BGA soldering maintenance platform. Ooh, fancy. Not bad. And in fact, the price on that was really quite good. In fact, the price on that I got through Banggood, I don't know, a month ago, is better than the price that I just paid for another mat, the exact same one, on Alibaba or AliExpress today, forgetting that I'd ordered this one. So this is really quite good, actually. There is a ruler at the top, which I have a metal ruler that's cork-backed that I'll use for that. I've also got a square, so that won't be used. But look at this. There are small pockets here. This will be great for holding screws. For example, I have, yeah, these are all, what, M4, M2 screws? There's 100 screws in here, so you can imagine how tiny each of these screws are. The answer, well, you can see them against my hand here. The answer, very, very small. So this will be quite handy for holding those, although I need a better work surface to do that, but there we have it. Right, our very last item is from Guangdong, China, again. It's in sort of a dirty, maybe was once white, plastic padded bag. It's been sent probably, I don't know, parcel post, yeah, China Post, i.e. cheaply, but again, I'm amazed that people can send a product all around the world. I like what I'm seeing thus far. This is good. I know exactly what this is. I really like this packaging. This is quite good. It has, alright, so the envelope itself has a bit of bubble wrap packing. The item, which this is upside down, the item is protected further by another layer of bubble wrap packaging, which is wrapped a couple times around, and embedded into the pink ESD protection styrofoam. I really like what I'm seeing. In fact, I will order from this person again. I truly really like what I'm seeing here as far as packaging goes, which is nice. Whoops. Well, they've missed some of the pins here, well, they put in the effort, sort of. So that is probably still okay. It's good to see. At least they're cognizant. They're trying, right? I mean, that's a bit better than just slinging this into an unpadded envelope. Okay, and I've got... Yeah, this packaging's a little bit weird, actually. There are stickers. I don't... Yeah, of course, they're all stuck. Why would you do this? Why? Oh my god, why would you do this? Wow, okay. Well... okay. Well, I understand. Yeah, this is really just not smart. They've tried, but yeah, the idea was good. Implementation was awful because now I have wacky, sticker goop all over my my device. That's okay. So what this is, I need to grab another board here. I need to grab another breadboard. Let me grab an MB102, which again is the 830 tie point breadboard. This actually provides power rails, power and ground. It is a quite good, and I'm saying it. There are a whole bunch of designs and versions of this same circuitry. It is effectively a step-down regulator that moves from, what is this, like an LM11311. Yeah, it's an AMS 1117. It's 3.3 volt regulator. There's also an 1175 or 5.0 volt regulation. So effectively, you bring power in through either USB or barrel connector, which I think is like 6 to 9 volts or something. Okay, DC 7 to 12. All right, and you elect through jumpers here. Here we go. So we've got out 1 and out 2. This is quite good. So these can be independently controlled. This is really quite good. So for example, I'm going to set out 1 to 3.3 volts and then out 2 to a 5 volt. So what this means is that, let me mount it up on the board first. Out, ground, ground. Yeah, that's good. The colors match as well. This is really actually not bad. Okay, there we go. Right, so it's mounted up. So on this rail, right, we've got our ground rail here, the blue, which extends all the way down. And we've elected this is output 1. We've made this a 3.3 volt rail. So VCC over here is 3.3 volts. VCC over here is 5 volts. And again, that's through our jumper settings. The circuitry on these is typical. It is the same thing you've seen everywhere. It's the same thing, for example, as this, right? Very, very similar. Everybody does this. Everybody kind of knows this. Everybody does something a little bit differently. The one that I've installed here has a couple beefy caps. This one is beefy caps. That's my old one. They'll all pretty much work. I'll have to actually hook them up to the DMM and just make sure. Yeah, this is quite good though. Not bad, but this is how you use these devices. The good ones are curved, sort of boomerang or banana shaped like this, which means you can still access pin 1. No, you can't really. Well, you can access maybe pin 3 onward. I've got another one on another board over that way behind me that gives you full access, but that's not bad. Certainly for what I paid. I think there's 5 here, and I paid $3 US with free shipping. Yeah, you know, I don't know. Could I even build this for that price? Yes. Now, here's the trick. If I include my labor time, could I build these for that price? No, of course not. Right. That's pretty good. So, I received a new mat. I got some breadboards. I got the power. God, what do I want to call these? Like, what would you type into the eBay search? I would probably call this like USB power supply breadboard. Yeah, that's probably what I'd call this. And you should see 1,000 connectors that look more or less like that. So yeah, as far as you know, packaging goes, I think their packaging person knows what they're doing, but the sort of inventory person maybe needs to be clued in a little bit to, you know, maybe they need a little bit better system of mounting these stickers and then doing all the rest of the work. But not bad. Certainly nowhere near as bad as it could be. Nowhere near as bad as I've seen, and I probably should get a foil bag for these, actually, and just load them in. Okay, and that's not going to be nearly enough. That's fine. I'll probably put them on styrofoam and or put them on the foam and store them in my parts bin of doom, which is right here. It's underneath the camera. It is an Akron Mills 64 compartment parts bin. It's quite nice. It's plastic. It's I'm not quite sure if it's ABS or I'll bet you it is. Anyway, it's some injection molded thing. Has a whole bunch of clear, translucent plastic bins, and you pull them out. You put things inside, and now I'm telling you how storage works. So, fantastic. What a great learning channel this is. For example, this is a bin. I'm using it to hold, as you can see, I'm just using it to hold 7-segment displays. These are, what, 6-digit? Yep, these are 6-bit 7-segment displays. And then I've got these, which I think are 5-bit. Is that right? No, these are 6 as well. That's fine. And of course, they're common. Either anode or cathode. I don't remember which at this point. I've got the data sheets on these, so I can look that up. And these work by multiplexing. So, yeah, 7-segment displays are really, really quite interesting. But instead of okay, so then each display conveys 8 bits of information, right? So 7 seg is 7 LEDs, and then a decimal point, right? So you figure 8 bits, 8 data lines going in saying either turn on or turn off. Now you can see that would add up to a lot of data lines going out if you wanted to, run all of these segments at the same time. It'd be, in fact, 8 by 6, so that's what, 48. You'd need 48 data lines, which I don't have. So, how do you circumvent that? Well, what you typically do is get a shift register, which is a what is it? It's a 74 something, 74 HC14N. Is that right, or is that the hex? In any event, you can get a shift register, and there are many of them out there. It's a 74 series is what you're looking for. And you can use that and sort of multiplex such that you like stripe your data along. So many times per second, these digits get refreshed. So in effect, it works a lot like a scan line of an old CRT monitor. So without getting too far into the weeds, that means you don't need 48 data lines to run this, this module. In fact, I think I've got, what, 10 pins? That would make sense. Yeah, that would make perfect sense because you have your segment display. You probably have like a bit select, and then you have a common anode or cathode, depending on what this is. That makes sense. Why you'd have 10 there, so that's fine. Right, I think we're done with our mailbag for the day. So I think one of the things that I will do, probably the first thing that I'll build in this channel, will be something we received today, which is the transistor tester. Now you'll see this sold everywhere because it's based on I think it's German, some German guy in the world. Thank you, unnamed German guy whose name I've forgotten. If you know who he is, comment, please, because I want to give attribution. In any event, some guy out there in the world, somewhere in Germany, came up with the design and open sourced it and said, hey, here's a good way that you can test transistors. And of course, once you do that in the world, you get, 1,000 different variants and 1,000 different vendors, because, let's face it, the cost of materials is less than what you can get selling this as a nice kit, which is what I've got here. And that's fine. I have no issue with that whatsoever. Mainly because, the silk screening on this looks really good. I tell you, the solder mask looks really good. Everything's tinned, so they being whomever manufactured this, yeah, they have some good pads on here. They've also got liquid tin that they've soaked the board in. So you're actually yeah, this will be really quite nice to work with. And of course they've got a box of random components and a case, and the case is quite good as well. I will probably build that first. That will be the first thing that I'll build on the channel, and I think I should have a barrel power connector. I do. There we go. Okay, good. Hopefully that will be center positive. Just trying to look for the connector. It should be right there. I don't see any information on it, but one would believe that it's going to be center pin positive, as all of our devices these days tend to be center pin positive. So yes, that is something I'll have to look up beforehand. In any event, that's the first thing I'll build. The second thing I'll build is this kit, which is, of course, the DS0138. That is an oscilloscope DIY kit. That will be really very cool to build. And this is a kit that I bought off of, I think I bought this off of Banggood. And this actually is a mixture of SMD, so surface mount device, or SMT, surface mount technology if you prefer, and through-hole. So, for example, you can see, yeah, there's some resistors. The regulator, the voltage regulator, the LM1117 33, and the Atmel. Actually, maybe not. Hang on. No, it's not an Atmel. It's a it's an STM32F. So it's another kind of microcontroller. In any event, it has some SMD devices that are fixed. They're already soldered. Using obviously a mask and paste and heat. And then the rest of the board is through hole, and I will be soldering various bits and pieces out of the parts bag here. I'll show you the parts bag. So that will be my second build in the channel. The first being the transistor tester, and the second being the oscilloscope. It's a very, very exciting time to be a hobbyist or a quasi-professional in electronics. It's really quite exciting because you can buy all of this from China directly. Now, of course, if you want to build for production, you don't buy from China directly through eBay or AliExpress or something like that. That's not how it works. You go through Mauser or DigiKey or what's the other big one? Octo something or other. Like for example, for the 18 mega chips, I'm going through Microchip directly because, well, a couple reasons. One, it's something that I think is good. I know the product-ish. I think, you know, it's a microcontroller that can do what I want. I can use it for prototyping and testing with the Arduino training wheels. And then I've got Atmel Studio, with which I can then, later on, as things get more complex, I can just write directly to the controller itself. I can just write microcode. So there's all sorts of exciting things for me, but it meets technical specifications. So I'm now looking at moving away from the 328 line and looking at moving to the, oh god, it's like an AVR. It's an ATmega 32U4. That is the chip I want to use. The price on it, I need pre-orders. I need to take pre-orders, and I need to break maybe 500 for that to be priced really attractively. But it is the part that I want. It will do what I want. I can convert it. I can. I don't have to use a 340 CHG USB chip. Let me actually, now that I'm just randomly spouting out numbers, let me show you what that looks like. So these are the 12 megahertz crystals that drive this, and these are, what is this, like a SOP 16 package? I think that's right. Anyway, this is or these are CH340G, or let me take a look. These are CH340G. I don't know, ICs. These are packages. What these do is these, well, this is a USB to serial communication module, right? So they take incoming USB signals, convert it to serial, talk to the microcontroller, and then, you know, it goes back the other direction as well. But what I'd prefer to do is use the Atmel, the 32U, the ATmega 32U4 microcontroller, because that has a built-in USB interface. Now, you know, so what? Well, the so what is this. The so what is that I can then make my board look like an HID device, right? I can make it, for example, if you've heard of the, I might have one here. If you've heard of the Arduino Leonardo. Yeah, here we go. I've got one right here. It's an Arduino Leonardo revision 3. If you've heard of this board, this uses, yeah, here we go, an ATmega 32U4 AU. This is exactly the part that I'm talking about. It uses this chip, which again, the AU just means it's a a TQFP 44-pin chip. That means it's just going to be mounted to the PCB in the way that you see here, with very, very tiny. So again, this is my finger. This is a letter opener, right? Your typical just letter opener. And yeah, you can see how tiny those connections are. But in any event, this particular chip will let you, for example, use a Leonardo as a mouse, or as a keyboard, or as a game device. So you can actually use it, for example, in Windows. You know, if I program this to be a game device, then I have, I don't know, something coming off here, like a wire coming off here that goes to a button. I can actually write microcode in here to tell this device that, hey, you are a joystick. And then Windows will come into play, right? Plug this in. Windows will come into play and say, oh, hey, I found a one-button joystick, right, with 0 axes. Do you want to set it up? And I'll say, yeah, sure. And you're done, right? No big deal. That is the kind of flexibility that I really want for my device, because I'm looking to build some hardware to interface with the computer, and that is the kind of thing that I would like. I don't want users to have, you know, horrible, wacky configuration file nonsense. Now, I will end up writing a driver because I have to, unfortunately. My device is input as well as output, so I need to get data back from the computer, and that's why I need to write that driver. But, you know, I'm trying to minimize that code and do as much in hardware and sort of leveraging, you know, all the inbuilt operating system services that I can, such that, you know, if you're on a Mac, you plug it in, it works. You're on Linux, you plug it in, and it pretty much works. You're on Windows, you plug it in, and it works, right? That's the goal here. I don't want, you know, users to have to go through a long, horrible configuration process. And in fact, what I'd like to do is, if they don't care about the device sort of syncing up to the computer, I'll let them run it without a driver, where they can still send commands from the device to the computer, and that should work fine, and in some cases, maybe that will work fine. But I know I don't like to have any more software running than I have to. And there are probably people like me out there, and that's fine. I'd like to give them that option. It will take a bit more work from me, but that's okay, because I think long term, right? I don't think about the next 2 months of painful software, bolting together. I think of, okay, when I develop a device and put it out into the world, I don't want to hear about it ever again, except for maybe, wow, this thing is great, thanks. Can I buy another one? My friend saw this and he wants one. That'd be great. But what I don't want is, oh my god, I installed this thing and what a pain it is to get this thing to run. I don't want that. So I'm fine with investing time at the front end to sidestep that issue. So really, I will make my life more painful to make the lives of people who spent money with me easier. And I don't I cannot fathom why this is not a common thing that is done. You know, if you have people spending money with you, trusting you, why not make it easy for them to spend money and just to enjoy your product? Why not do that? In any event, that's my goal. So, right, yeah, we're getting more parts by the day. We're building up the sort of mad scientist lab here. I've got all the LEDs I will ever need. Got them in red, I've got them in yellow and green. Again, this is all test bench stuff, right? So nothing that you see here will ever make it out into the real world. This is all for me to experiment with and prototype with. None of this will ever see the real world. The closest that I might come is when I build, because I'll probably build a limited run of maybe 3 devices, and I'll probably use this, actually. But I'll build a limited run of 2 or 3 devices that I will put into the world, and I will probably, because I'm interested in how things work, right? So I will probably do all the etching and the photolithography work, and you know, the design layout and everything else myself. For those 3 units, that will all be hand built in this room, which sounds kind of chaotic. It's obviously not what you want to do at scale, but for 3, and for getting hardware into the world and tested, I think that's perfectly fine. But then, of course, from there, you know, I've got KiCad running, I've got some other software running, I've got a way to get Gerber files out into the world, but that will go to probably a PCB house. And for my enclosure, I've got a 3D printer coming, but I may go injection molding on that with ABS. I'm not quite sure which way I want to go yet, because I've never 3D printed before, so I want to see how clean the lines are, and if I can get the finish I want with maybe like CA, which is super glue, fuming, and or maybe just acetone fuming to sort of take out some of the groove, the layer lines, right, the grooves. I'll have to see how that goes, but I'll probably move toward injection molding, which I won't do, because I'm not set up for that here. That I'm going to push out to, again, probably China, and I'll do final assembly testing and sort of QA work back here locally, and then ship the units out for, well, for delivery. It'll be good times, but it is going to be an awfully long run. I think, I mean, we're about to hit September here. Most of the circuitry is planned out. The schematic's done. I think ERC, so electrical rules check, I think that looks pretty good. I just want to make a couple of you know, part changes, and then I will start breadboarding, and then start writing software, start writing microcode, which for me is going to be the faster part, probably, except for the driver. That's going to be a little bit interesting, but in any event, I'd like to have a Kickstarter up for December, so you know, so you kind of start working backwards, and that means I need a prototype out, built, and tested by really November. So 2 months is what I've got to go from random parts on the bench to prototype-worthy product. So, if you've enjoyed it, that's great. I like electronics, and I've been away from it for years. I'm glad to get back into it. If you like this channel, you'll really like BigClive.com, all one word and spelled out. You'll probably like Dave Jones at EEV Blog. You'll probably like there's a German guy called Great Scott with exclamation mark. And also, I think it's Ralph S. Bacon. Anyway, he's a fellow Limey, so they do good work and have interesting content. So if you like what you see and you want to see somebody with a bit more of an established setup, go check those people out, because they put together some really interesting content. Likewise, if you like what you see, subscribe, like, follow, etc., etc. But I'm not fussed. Do whatever you want to help you remember to come back and check in again and see what I'm doing. So I've appreciated watching. I've appreciated having a bit of a show and tell here, and we will do it again at some point, and maybe I will mount the camera in a little bit more of a sane way. Thanks for watching, I appreciate it, and I will see you next time. Be well.